All right, here we are finding the simplified explicit formula for this more complicated series. So simplified, I'm going to try and get it as simple as possible. I see that my first term is 8. It looks to me like I'm halving and multiplying by square root of 2 each time. So let's check that. So my assumption is r is equal to root 2 over 2. So 4 root 2 divided by 8, that does equal root 2 over 2. I need to test it again. 4 divided by 4 root 2, that's 1 over root 2. But if I multiply the top and bottom by square root of 2, I get root 2 over 2. So that is my r value, root 2 over 2. So an is going to be 8 times root 2 over 2 to the n minus 1 power. Well, it said simplified. So I'm seeing 2's here, and I know 8 is 2 to the third, so I'm thinking about my exponent rules. So I'm going to start using them. This is 2 to the third times 2 to the 1/2 over 2 to the 1 to the n minus 1. That's going to give me 2 to the third times 2 to the negative half. I subtract those two to the n minus 1. 2 to the third times 2 to the negative 1/2 n plus 1/2. That's the same as 2 to the third times 2 to the negative 1/2 n times 2 to the half. Now I can combine those two. That's going to give me 2, let's see, 6 over 2 plus 1 over 2, that's 7 over 2, times 2 to the negative half n. I'm going to put those back together. And now that I've shown this, I'm going to delete that part so I have some more space. So there was an n here. That's going to be the same as 2 to the negative 1n plus 7 over 2. And this is a pretty simplified version. This looks a little bit like an ln. I'm going to come back and just write it as n. It was 1n, but I'm going to come back and write it this way. So here's my simplified as I can get it explicit formula. And yeah, if we want to look at this another way, I'm going to show you that in class. So make sure you ask me in class to see another way to get this version of the formula, because it's really nice and it connects to arithmetic sequences.